In this podcast, we're going to talk about what a haloalkane is, and we're also going to talk about both IUPAC naming of haloalkanes as well as common naming of haloalkanes. All right, so a haloalkane is where you have a halogen atom, so chlorine, fluorine, bromine, iodine, all those guys are replacing one or more hydrogen atoms. So it's no longer just a hydrocarbon, carbons and hydrogens making up a structure. We now have a halogen present. For the IUPAC naming, it's going to be the same as everything else that you've seen before. However, we're going to change the end of the halogen's name from INE to O. So for example, chlorine changes to chloro, and that's how we would name it as it's part of an organic structure. As you're naming this, all the same rules are going to apply. You're going to make sure that you find the longest chain first. You are going to number the carbons so that your branches have the lowest number carbons possible. That means you may have to count left to right, right to left, up, down, up, and then you're going to alphabetize all of your groups or your substituents. So let's start. We have, and I'm going to count both ways just so that you can see what you're supposed to do on quizzes and tests. 1, 2, 3, 4, 5, 6, 7. So my parent chain is 7 carbons long. And I'm going to count the opposite way just to see how my groups play out and if I'm giving them the lowest number possible. So, I forgot to draw a line through my parent chain. So there's 1, 2, 3, 4, 5, 6, 7. I like using different colors for this because it helps my eyes to see the 2 different ways I've counted. Totally your call on what you want to do. All right, so looking at the green numbering system, I have a methyl group, a branch that's not part of the longest chain on position 3, and I have a chlorine on position 6. If I were to follow the red numbering scheme, I have a group on number 2 and a group on number 5. So now the goal for me is to pick the lowest numbering system possible for these, and that's the direction I'm going to have to count. So 2 and 5 are lower numbers than 3 and 6. It's a good thing I thought to count backwards with the red, or I would have missed that. That's a common mistake. So let's let that sit for a moment and start naming. Always start with your parent chain. This is 7 carbons long. The prefix is hept. It's all single bonds. I see nothing double, so heptane. Now I'm going to alphabetize my groups. This is chloro, and this is methyl. Despite what the numbers are, you have to say the name in alphabetical order. So even if chlorine was a higher number, it would still have to come first in the name. In this case, it's the lower number, so nice and confusing for us. All right, so my chlorine is in the 2nd position. So it gets to go first because C comes in the alphabet before M. So this would be 2-chloro. And I'm going to use dashes in between numbers and letters. My methyl group is next alphabetically, and it is in position 5. So 2-chloro, 5-methylheptane, methylheptane being one word, no spaces. All right, so if you're feeling confident about this, feel free to pause me, try these problems, and then check back in to see if you got them right. And if you didn't, you might need to watch it. All right, so this first one, we're going from a structure to a name. So, oh man, I hate this. I hate when we further condense this down and use subscripts because right now reading this, it's easy to say 1, 2, 3, 4, this is butane for my parent chain, and it's not. So what I'm going to do is I'm just going to write the longest chain above it. So there's 1 carbon, 2 carbons, 3, 4, 5. So this represents 3 carbons, 6. There are 6 carbons in this parent chain, and that can be very misleading. So be very careful of that on tests and when you're working through problems. So my parent chain is hexane. It's a straight chain, no need for the word cyclic. And I have a bromine or a halogen coming off of that. I'm going to count both directions to make sure that I assign it the lowest number possible. So counting left to right, 1, 2, I don't need to count the rest. That's as far as I need to go for that. That's a pretty low number, but let's count backwards. 1, 2, 3, 4, 5. Nope, we're not counting right to left. that gives us a much higher number. So let's go with the purple numbering. Always, always, always state the number your carbon is on. So this is 2-bromohexane. All right, on this next problem, we are going from a name to a structure. So let's go ahead and take a look at the parent first, and then we'll worry about putting our groups on as needed. So the parent chain, and this is hexane, but be careful, it is cyclic. It's easy to gloss over that and miss that. So cyclohexane means I have 6 carbons in a ring structure. So it's going to look like a hexagon. So I always like to count when I make them. 1, 2, 3, 4, 5. I don't know what I'm doing. I just did something weird. 1, 2, 3, 4, 5, 6. Okay, so I have 1, 2, 3, 4, 5, 6. You're going to get really good at drawing this shape by the end of the semester, I promise. All right, so that is my parent structure. So I'm going to cross that off. Got it, done, check. Next, I see that we have tri means 3. We have 3 bromines coming off of this structure, and it's in positions 1, 1, and 3. Notice the repetition. You have to say, even if they're on the same carbon, you have to address that 2 of those bromines are on carbon number 1. I'm the boss. I'm drawing this. I get to put my carbon number 1 wherever I want. I like putting mine over on the right-hand side. So there's carbon 1. Okay? Took care of 1 bromo. My next bromine is on carbon 1 again. Done. My next bromine's on carbon 3. So this is 1, 2, 3. So I need to draw my bromine coming off of the third. Doesn't matter where you place them on the ring, just so long as they're the right distance apart and you have 2 bromines on the same carbon. If this were a quiz, a handwritten quiz, or problems I'd be doing, I would erase those numbered carbons. I cannot do that on the PowerPoint for you though. All right, so finally, that was the IUPAC naming of haloalkanes. We can also use common naming for this. This isn't done as often, but it's good to know in case you come across some of these more simple haloalkanes. So they are named as alkyl halides. So we're naming them similar to how we'd name an alkyl branch. So if you had a 1-carbon branch that was an alkyl branch, you'd name it methyl or ethyl or propyl or butyl. That's what we mean by alkyl halides. And then you would name, so you're going to name the carbon atoms as the alkyl group, and you'll give it a space. It's a 2-name name. And then you're going to name the halogen, and you're going to change the ending, say, of chlorine to chloride. So similar to what we did for ionic bonding. So in this first example, we have 2 carbons in our parent chain, if you will. So that alkyl group is ethyl. And we have a chlorine, which we change to chloride, ethyl chloride. This is for very simple haloalkanes. You wouldn't see this for more complex ones. We defer to the IUPAC naming system. For our next example, 1, 2, 3. 3 is prop. Because it's an alkyl group, we add the YL, propyl. Fluorine becomes fluoride. Biggest pet peeve is when we misspell fluorine. Make sure you're not writing flourine. It's F-L-U-O-R.